So now we understand that. Now let's go and walk through a few examples of how electrodes detect charge, again considering only the positive electrode. So let's say you have a box containing 5 positive charges. Great. Now you're going to put your electrode, your positive electrode, into that box, and then you're going to detect some kind of charge there. And recall that when you detect a charge, it's detected in the form of a voltage, or the potential of those 5 charges to move from their state of positivity down to where the negative electrode is going to be. All right, so if you were to graph what the electrode is seeing, the plot would look something like this. Your x-axis would have time. Your y-axis would be voltage. And then this is where 0 volts is. And you're detecting 5 charges, and since the charges are positive, let's say the electrode is seeing a flat line somewhere up here, which is plus 5 charges. Simple enough. But now let's say that your electrode is sitting in a box, the same box, but instead of it just having 5 positive charges, it also has 5 negative charges. So now what do you expect the electrode to detect? Well, since the charges are balanced inside the box, you're going to detect no difference or no voltage. And again, what that means is there's no difference in the amount of charge that is being seen by the positive electrode and the amount of charge being seen by the negative electrode, which again is sitting in some solution somewhere else that is electrically neutral. So that's your negative electrode. And the two, of course, are connected by a wire with a voltmeter, which is what is reading out the voltage. All right, so that was pretty simple. But now let me introduce another concept to you. So let's say you have your box again, your box of 5 charges. And now let's say that you have an electrode here. So again, you're going to detect a positive voltage. And let's say for now that that voltage is somewhere up here. Now I'm going to mark another positive electrode position, and let's say it's somewhere out here instead. So it's farther away from the positive charge. Let's say that our box has gotten bigger. So the positive charges are still inside the box, but they're sitting somewhere in the middle, and our new electrode is sitting out farther away. So now what do you expect to detect? So what you would expect from this second electrode, it would read a positive voltage again, but instead of reading it somewhere out here, like what we saw for our black typical electrode, you're going to see a lower reading somewhere out here instead. And the reason is because the farther away the electrode gets from the charge, the lower the amplitude of the voltage it's going to see. But the take-home message of this is that no matter where you place your electrode, whether it's here, 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 or here, you're still going to detect positive charge. The issue is how high the voltage, or what the magnitude of the voltage is going to be, is going to change depending on the distance between the electrode and the charges that are going to be detected. And this can theoretically be taken to a situation where the electrode is an infinite distance away from the box, where it would still be able to detect an eensy bit of charge, but that eensy bit is so negligible that we call it 0. All right. Now let's introduce another concept. So we have talked about how the charge would be detected based on different aspects of space. That is, how far away your electrode is from the box. But now let's think about electrodes in space a little bit differently. So imagine you have your box of charges, again, and you accompany it with another box of negative charges. Okay, great. So now let's say you have one positive electrode right here. So what will that electrode see? Well, let's go back to our voltage plot. And what this electrode is going to see, this electrode right here, it's going to see the positive charges more strongly than it'll see the negative charges over here, because, let's face it, it's so much closer to those positive charges than it is to the negative ones. So we would expect our positive charge, or our positive voltage reading from that electrode. Now let's go to the opposite situation, where our electrode is now right here. Again, this is our positive electrode, but it's seeing negative charges. So what will you expect on your voltage plot? Well, since this green electrode right here is so much closer to the negative charges than it is to the positive ones, you would expect a voltage reading somewhere out here. All right, now here's the catch. What if you had an electrode whose tip was right here, dead center, between the positive charge and the negative charges? So the distance here is the same as the distance there. Well, in that situation, since the electrode is an equal distance between the positive and the negative charges, it's going to see them equally. And so it will balance them out. And it will detect a voltage of 0. Because to this electrode, there's really no difference in what it's seeing compared to what the negative electrode sitting in its neutral solution is seeing. So what do we understand from these points? Well, first we understand that electrodes detect charges by comparisons. And the second thing we realize is that electrodes can detect charges at any distance from the charge. And the final thing we've learned is that electrodes can detect the charges not only at any distance, but also at any angle compared to the charges. And these concepts are extremely important because for an EKG, the distance the probe or the electrode is away from the heart, where all the charges are moving, is actually quite phenomenal. So say this is your heart. Now, what we would love to be able to do is to put the electrode right inside the heart and say, how are the charges moving inside the heart? But then you'd have to cut open the person in order to get to their heart in the first place. So what many doctors do instead is they sit their person down in the office. They ask them to lie down on the table. And instead of piercing open their chest and sticking in the electrode, what they do is they put the electrode right on the patient's skin. And surprisingly, even though the distance between the heart and the skin is pretty large, the electrode can still detect a voltage, meaning that it's detecting a moving charge. And that's really, really important because that means that you don't have to cut open the patient and you can still see something about their heart. Now, the third point is also important because we don't just place electrodes in one position on the person's chest, we actually place them all over the person's body. And from these many different angles, we can detect what's happening inside of the heart.